In this video, we're going to look at the laws of logarithms, and there's four laws that we're looking at: the product law of logarithms, the quotient law of logarithms, the power law of logarithms, and the change of base formula. Your handout may look slightly different than the handout that you're seeing on your screen right now, and that's because in this format, we are not going to prove the various laws of logarithms. What we're going to do is we're just going to take a look at these different laws and see how they can be used in various contexts. It should be noted, however, that there are no laws for log m plus n base a or log m minus n base a. These are two common errors that students make when studying the laws of logarithms. This is the format of the product law of logarithms. This is the format of the quotient law of logarithms. As you can see, it is very different from this right here. Okay, we're going to skip to the first example. So if you could turn to page 13 of your package, you should be on the first example. Okay, so here's the first example that we're looking at, and it may or may not be on page 13. I'm not quite sure what the page number is, but this example should appear in your package in this section. So the first example asks to simplify the following expressions: log 6 base 3 plus log 4.5 base 3. Okay, so we have to simplify that logarithmic expression, and we need to use our logarithm laws to do so. So what I'll do is I'll paste the logarithm laws on the screen right now, and we can take a look at them and see which of the logarithms that we are likely to use. Okay, so here are my logarithm laws, and I see log 6 base 3 plus log 4.5 base 3. Okay, that to me looks like it's going to be the product law, because I have two logarithms that are being added together with the same base. Two logarithms added together with the same base, a base of 3. So it looks like I need to use the product law of logarithms right here for this question. So what I'll do is I will say, in this example, this is equal to, so log 6 base 3 plus log 4.5 base 3 is equal to log bracket 6 times 4.5 base 3. Okay, so that's what that should equal to. We take the two numbers right here, we multiply them together, and we put it to the same base for the logarithm. Okay, and what we end up having here is, one second, let me just change this. Okay, great. So we have log base 3 and then 27. And so the final answer here is log 27 base 3 is equal to 3. Okay, if we take a look at this next one right here, I'm just going to move my formula sheet right here. Again, we have the same format here, except the base is 2. So I'm going to do pretty much the exact same thing. I'm going to say this is equal to log 3 times 48 base 2. And 3 times 48 base 2 is equal to 144. So log 144 base 2. Now the issue here is that 144 is not a perfect square of 2. So 2 raised to some exponent does not equal to 144. So in order to evaluate this logarithm, I'm going to need the change of base formula because, you know, using a calculator, the calculator logarithms are always base 10, so I can't evaluate this logarithm without changing the base. So I'm going to put a little note right here, and I'm going to say right here, use change of base. Okay, so this right here is simply going to be equal to, if I look at my change of base formula, log 144 base 2 is equal to log 144. Okay, so log base 10, 144, all over log 2. So I used the change of base formula so that I could evaluate this logarithm. And that's again because this logarithm right here will not produce an integer value. Okay? And that is approximately going to be equal to 7.2. Okay, and there's my final answer. So, just to review, I multiplied these two numbers because I used the product law of logarithms. I recognize that this would not produce an integer value because there's no perfect exponent on 2 that will produce 144. So in order to evaluate this, I used a change of base formula and got 7.2. Okay, looking at the next example, and I'm just going to keep moving this around so that we have it as a reference. Okay. Looking at this next example, it says simplify the following log expression solely in terms of log x base a, log y base a, and log w base a. So this complicated log expression here, I'm going to take that expression and I am going to then use all of these logarithm laws to really simplify it. Right, so this looks pretty complex. You've got x to the power of 6, y to the power of 3, all over w squared. And then you have to take the cube root of that, right? And that's a logarithm. So let's simplify this a little bit, okay? All right, so we start over here. We're going to rewrite this, and I'm just going to rewrite the entire question. So log base a cube root of x to the power of 6 times y to the power of 3 all over w squared. Well, I know that all of this right here is the cubed root, so I'm going to take this right here and I'm just going to change the way it looks. Right? I can do a cube root as an exponent. So what I'm going to do right here is I'm going to say log base a, and then in brackets I'll put x to the power of 6, y to the power of 3 all over w squared raised to the power of 1 over 3. That's the exact same thing. Now I can look at my laws here. Well, when I have log of something, base a, then raised to that exponent, we see with the power law right here that the exponent then moves down in front. So if you have log of some number, base a, then that number is raised to some exponent. That exponent becomes the coefficient of the entire logarithm. So what we're going to do is we're going to take this 1 over 3, and that 1 over 3 right there is going to be brought down in front and is going to become the coefficient. Right? So I'm going to say right here, use the power law. Okay, so we're starting to simplify this by using a power law. And so we write 1 over 3 log base a, and then x6 y cubed all over w squared. Great, so I no longer have that exponent. That's been brought in front. I notice that over here I can use the quotient law because I have one thing divided by another. Right? I've got one thing divided by another base a. So I'm basically going to use my quotient law here. So I'm going to write use quotient law. And numerator divided by denominator. So log numerator minus log denominator, right? Log numerator minus log denominator. So I'll take this 1 over 3, keep it here. Okay. And then in brackets, right, because this is a coefficient, I'm going to write log base a of the numerator, a6 y3 minus log a w squared, so minus the denominator. Okay, so now I've effectively taken this, which was a quotient, and I've split it up into subtraction by using the quotient law. And now what I'll do here is I'm going to split this one up because it is being multiplied. I can use the product law. So I'm going to write use product law. And that will allow me to split up this one right here. So I'm going to rewrite 1 over 3 log base a x to the power of 6 plus log base a y to the power of 3 minus log base a w squared. Okay, so I've split this up right here by using the product law. As I saw, I had two things being multiplied, so I could split them up into addition of logs. Now, what you may see again is that we have these exponents here on all these numbers, 6, 3, and 2. Okay, inside the brackets, I have those exponents. So you may be thinking to yourself, can I use the product law again? Or sorry, the power law again? Absolutely. So you're going to use the power law again. So we'll just write that. Use power law. Okay. On an assessment, you definitely don't need to write which law you're using. I'm just doing it to help you guys see how we're going about this, right? So you're not missing any steps. So 1 over 3, and again, that exponent is going to come in front of the log. 6 log base A x plus 3 log base A y minus 2 log base A w. Okay, so all those exponents became coefficients right there. So we took that one, that became there, or that one moved here, and this one moved here. All right, now it's a simple matter of expanding into the brackets or distributing that 1 over 3. So again, I'm not going to skip any steps. You definitely don't have to show this step if you don't want to, right? But I'm not going to skip this step. So I'm going to take 6 and multiply it by 1 over 3. So I get 6 over 3 log base ax plus 3 over 3 log y base A minus 2 over 3 log w base A. Okay, and then further simplifying, that's just 2 log x base A plus, that's just 1 log y base A minus 2 over 3 log w base A. So as we can see here, I started with this complex expression for this logarithm, and now using all the various laws, I was able to break it down into something much simpler. So this is how to simplify a very complicated expression using the logarithm laws that are shown. Okay, so I'm just going to move this now right here. I'm going to move my formula sheet up here. Okay. Let's see, actually, maybe I'll move it down. That might be better. Yeah, moving it down right here. Okay, so this next question says, prove that log 5 base 2 plus log 1 over 5 base 2 is equal to 0. So when we have proofs, what we have to do is we have to break that up into a left side and right side. So every time we have a proof, we have to separate the left side of the equation and the right side of the equation, and we have to show that the left side is equal to the right side. So I'm going to write over here left side, and I do basically like a T-chart here, and I use right side. Okay, so I know that my right side is equal to 0. I'm not going to touch that. But my left side is this more complicated expression right here. Okay, so what I'll do with this left side is I'm going to go is equal to log 5 base 2 plus log 1 over 5 base 2. Looking at my logarithm laws, I can see very clearly that that is a product law. So I'm going to change it from this addition back into multiplication. So then log 2, and then multiplying these two numbers together, 5 times 1 over 5. Well, 5 times 1 over 5, the 5's cancel, and I'm just left with 1. Log 2, log 1 base 2. So this asks me, what exponent on 2 produces the value of 1? Well, that's 0. And so I have now proven that this right here is equal to the right side. So I say, therefore, left side is equal to right side, and therefore, log base 2 5 plus log base 2 1 over 5 is equal to 0. Okay, so again, set up my left side and right side, put my left side in, put my right side in, and then use the various laws to achieve the final answer or achieve the proof. Okay, keep going right here. So it says right here, write 2 log 5 base 2 plus log 13 base 2 as a single, and I've got to move my formula sheet here, as a single logarithm. Okay, all right, so what I might do here is I might just shrink this and put this over here so we still have it, we can still see it, but it's not intruding on this area. All right, I see this 2 in front of this logarithm, and I realize I can't just use product law right here because there's a 2 right there. But whenever I have a coefficient in front, I could reverse it and put it up as an exponent. So I could take this 2 right here and using the power law, put that as an exponent on the 5. So I'm going to rewrite this. Instead of writing 2 log 5 base 2, I'm going to reverse the power law and write log 5 to the power of 2 base 2 plus log 13 base 2. I have to apologize right now if you're hearing these mouth sounds. My dog is making mouth sounds into the microphone, so I apologize for that. Okay. So then I can just evaluate log 25 base 2 plus log 13 base 2. And now that I have the same base and I'm adding logarithms, I can use my product law. So here we go. Log base 2 bracket 25 times 13 right there. And so that becomes then log 325 base 2. Okay, and so that is the single logarithm. So I've taken something here and I've rewritten it as a single logarithm. Now, there's another kind of fancy way of doing this, and you can actually think of it like this. 2 log 5 base 2 is the exact same thing as saying log 5 base 2 plus log 5 base 2, and then plus log 13 base 2. Okay, so like 2 log 5 base 2, that's the exact same thing. It's just 2 log 5 base 2s, right? And then you can use your product law and just simplify. 5 times 5 times 13 is equal to log base 2 325. So that's another way of doing it as well. In this case, you would just have to recognize that 2 log 5 base 2 is the same thing as writing 2 of these log 5 base 2s in a row. That's a different way of doing it. Okay. Alternatively, as I said right here, you can reverse the power law and take that 2 and make it an exponent on 5 and then go forward. So you've got some options here. Okay, thank you very much for watching. Homework is listed right here. Have a good day.